So hello everybody, it's 10 o'clock here in Slovenia and we have a planned webcast for today to show you Electra by CGS Plus. So if everybody can hear me, just please type in the chat window that the audio and video is okay, just to give me a feedback. Okay, getting some feedbacks already. Okay, that's excellent. So for the start of the presentation, I have muted you all, and you can use the chat for any questions during or at the end of the presentation. So we will collect all those questions. The video or the webcast is recorded, so the video will be sent to you afterwards, and we will also answer to all those questions gathered today. So let's start with the presentation. Let's go into the presentation. So what we've provided is basically a new software, Electra, with the 2.15 version, which is available in English language. CGS Plus had basically Electra version 1.0 more than 50 years ago. And we have lately, basically last year, completely restructured all the functionality, and it's, as you will see, there are some quite new and let's say intelligent and other features which should provide users the tool that they are expected to have. Okay, so where is Electra used? The fields of use for Electra, we are basically targeting all the overhead power and distribution lines operators. So basically electricity power line distributors, telecommunications, cable distributors, all the municipalities which deal with the distribution of any kind of communication lines. But not only overhead, Electra can also be used for the underground power and distribution lines. So there is the functionality there to design the underground cables as well. Okay, so Electra, its installation, it's a part of the CGS infrastructure suite, which means that comes together in the installation of Platea, Ferrovia, Aquaterra, together with Electra. That's why, because there is basically some functionality in the software, especially in related to crossings of existing infrastructure, like other power lines or other roads, railways, river channels, and to have the ability to do the analysis, especially the security heights for the cables, etc. The supported CAD platforms are BricsCAD and all the AutoCAD verticals. Especially, let's say, AutoCAD Map 3D offers some extra functionality, which will also be shown in the video later on. Let's start with the functionality overview for the Electra. The first important thing is the supported standard. What we have implemented in are the Senelec standards, those mentioned here, from the 2009 and 2012 versions. The 2012 also defines the wind loads, and that standards are different for specific countries. So what we would like to ask you partners is to check those standards and provide us. We will basically email you what is needed to implement in the Electra. Currently we have in the Slovenian standard. There is of course the possibility for user to edit it, but we would like to implement those parameters in the local installations as well. Electra comes with a digital terrain modeling because of its support for the basically BricsCAD and plain AutoCAD and map softwares where there's no digital terrain modeling tool. So CGS DTM is already part of Electra, so that user can create any terrain from any ASCII file containing north, easting, and z values. Okay. Here is one part that was mentioned before. So if users are using map or other GIS functionalities, Electra works very well with it. So you can display the parcel information, the existing infrastructure information. So here is some underground existing infrastructure, so that the design can be, let's say, more precise and more accurate, and also in terms of where all the conditions are. So which parcels are available for you to design, where are existing infrastructure, basically, let's say, starting points or the connection to existing infrastructure and where to end it, etc. As you can see here in part, when we define the alignment or the power line, we can define its parameters, okay, its name, and we can also define to which surface it will be automatically projected, so that the creation of profile views is dynamic and automatic. But also the wind parameters can be specified for each power line. So there are the wind zones defined for each country, and also land category values for each country, and those two values are of our interest to implement in Electra, so that we can conform to each country's values, let's say, from the beginning. As user just install Electra and they have all the values implemented in correctly. Electra enables, those are some comparison to the old Electra as well. So in previous version there was only one conductor possible to be attached to the poles. Electra now provides the ability to add as many conductors to poles as user needs to, and define all the loads, the wind loads as presented, and all other parameters. Any changes, if created or made to the profile line, are represented dynamically in the profile view. So if user is just changing the layout of the profile, the profile automatically updates, and that's a significant improve in our software. Next thing is there are different tools to check safety distance analysis, especially the safety distance between the lowest conductor and the terrain line. Users have all the possibilities to dimension, heights, distances, slopes, etc., and make their own annotations. Okay. Another great tool in Electra is, as mentioned, the analysis of crossings. And here we can see the crossings between two power lines, and user is now able to check whether the vertical distance from the uppermost cable and the lowest cable of the two power lines are apart for the amount that's needed, let's say, and that analysis can be done based on different loads, different wind loads, parameters, etc. What's also important is that user can check the crossings towards other infrastructures like rail and road, where a needed 6 meter, usually 6 meter distance between the conductor and the upper point of any infrastructure is needed. Okay, and the last and let's say the most important thing is the production of conductor SAC reports, where basically all the conductor parameters are listed. So which cable was used, what's the span for that conductor, what's the base temperature used, critical temperature, minimal SAC, the calculation span, the load factor, the total catenary length, and all the SAGs from -20 to 40 degrees Celsius, so that users have the, let's say, all the preview of the seg for different conditions. The seg reports is made in an external ASCII file where basically all conductors designed in the drawing are listed. Okay, so here we've prepared a short video just to show you the functionality. So as mentioned, Electra comes in a CGS infrastructure suite, so it's a part of all of other softwares. So we have there the menu and the ribbon possibilities. We just start a new project, and here I've prepared one terrain just to show you how this digital terrain modeling tool can be used. It's just here an example. So we will create a new surface, and I will use an external file which has an X, Y, and Z data. Just click OK. So select that contours will be presented, click OK, and in a matter of a second or two, the terrain is created. So we will now move back to the ground, which I've created before. So we have here an underlaying of an existing infrastructure, and we also use some map functionality to show all the parcels, so all the land, and we are now just zooming in a part where we'll do the design of a new power line. So we will start an access manager, and here we can start from an existing power line listed or just create a new power line, basically new axis. This functionality is very similar to, to Platea, Ferrovia, Aquaterra, so you should be quite familiar with it. So we have other possibilities here to define description, starting, stationing, etc. And now we run the command to draw the power line. As you can see here, we have power line selected. If we have more surfaces, we can define to which surface the automatic drape will be created. Now we will just zoom in and start from, let's say, from this point where an existing infrastructure has ended, and we will now design this power line with an angle. So there are two sections of this power line, and as you can see in the layout preview, there are already some poles created at the beginning, at the angle, and at the end of the power line. We go to the profile view draw, and when we click in, so like this, we get the preview of those poles already. So the beginning pole, the pole at every angle of the power line and at the end are already predefined, but can be edited. So user can change their height and other parameters. Also, if you can see, when we change the layout, the profile view updates automatically, and that's a significant improvement towards our software possibilities. So we will now define a conductor. So here we selected the first pole, the first tangent pole, and on it we will now attach a cable. So there is a list of cables in an external XML file, which can be also edited, so users are able to add their own cables, especially some optical cables which are now very, very, let's say, modern and quite used, so can be added in. So we have now defined the cable, we defined the height of that cable, and that cable is now attached to the span between two tangent poles. And here, because there's a slope, the cable is always above the ground, but we will create, let's say, put another cable in the second section of the span, of the power line span, and you can see here that the cable basically interferes with the ground. So we need to add some extra poles here. We will just change from the tangent pole to the support pole, and we will now add those poles into the drawing. So The insertion of the poles can be interactive, as you can see, just by clicking that button. User can go in the profile view and click the location of the pole. Let's put in 2 more. So you can also see that the preview of the SEG is always available, so user has some information whether or where to put that pole, and also the stationing can be set specifically, let's say, to as needed. What is important here is the possibility to edit poles. Okay, we can edit the pole parameters and also their position. We can change the position in the profile view, as you can see here. And let's say for this example, we will just change the height of that pole from 10 meters to 11 meters. But what's sometimes even more important is the possibility to change the location of the pole in the layout. As you can see here, let's say this support pole has been put just on the edge of between 2 parcels, and maybe there is no right to put it there. So the designer has to move it, whether forward or backwards, to get to the proper piece of land where they will be able to put that pole. Okay? And the preview of those moves, if you were looking accurately, has been automatically previewed in the profile view. Okay, here we'll show the possibility to add more conductors to that power line span. So we always select the first tension pole on which we attach cables. We define some technical parameters for the cables, and then we have to define the attaching point. So basically the height at which the cable will be attached to the pole. So here we have now 2 cables added to this span section. And in the bottom you can see that here is the conductor's height and the poles attaching point heights represented, and bear in mind those values below. So we will now add additional pole, and the height of those bands is limited now, and as we add a 3rd conductor here, we'll put it on 8 meters on OK. So the bands are automatically updated, and also the height of those bands is automatically updated. So no need for users to edit those bands manually, adapt the heights, etc. So everything is basically done on the fly. Okay, so what we'll do here is make those safety height checks. So we can define for this lowest conductor whether it meets the 6 meters safety height toward the terrain, and as we can see here, that is met. But we can also check the safety height between 2 conductors, and we are interested between the uppermost conductor and the middle one, and here we will set a 0.9 meters of height. And when we go into the drawing, the red line presents that safety height, and we can see here that it interferes with the middle cable. So we have to change something, either physical data of the uppermost cable or lower the middle cable, etc. So what user can also do is label those safety heights. So we are just clicking points in the profile, and you can see in the bottom window that the safety heights are labeled in the band for safety heights, and we can also label those safety heights for, let's say, for a specific interval in profiles at some terrain points, etc. What's also important is the creation of a SEG report file. We just export that report to an external ELE file, which we can just represent here. We will just open it. It's basically an ASCII file, so let's see it here, with all the data that users need. So what is basically important is that the seg calculation is common in every country. What differs is only the loads parameters that can be assigned to the conductors, and that's an input value that needs to be done in the beginning. Okay, so some important facts about Electra. So the Electra 2015 version, the English version, is already available to download, and we will send you the link for it after this presentation. Expected code complete for the 2016 version is planned for end of March, and that's important because all of you, our partners, which are interested to have a localized version of Electra, will be asked to finish, to make all the translations for the UI and, let's say, all the localizations, especially for those loads and others, before the beta release will be published. For now, the beta releases are planned for end of April. So you can now see that those interested have the chance and the possibility to do all the translations until the end of April. There are two also important dates: the CGS conference, which will be on 13th May, where the new version, the 2.16 version of Electra, will also be presented, and the technical training, which is planned for 20th May, where we'll go more in details through the whole bunch of CGS softwares, not just Electra. Okay, testing and QA deadline is planned for end of May. Those are all provisional dates that might change, but these are planned dates, and we should look at them as that they will be, let's say, meet. And the 2.16 version release is planned for end of June 2015. For any, let's say, demonstration purposes that you would like to do to your potential customers, you can already use the existing Electra 2.15 version. Okay, so there's a generic version, and you can just present it, show it, get the feedback, and provide those feedback to us, which will be very welcome. Okay, so this is a general preview of, let's say, the functionality and the possibilities that we have in Electra. There are some other special ones which will be published and sent to you by emails, so that you will have an extra overview. If there are any questions, please just type them into the chat window, so maybe I can answer them right away, or just what we'd like to is also gather them, and we would answer them in the emails sent to you. So let's say we have now 2 or 3 minutes time. If there's any question, please just go ahead. I have also unmuted you, so if anybody wants to come forward, you can speak. If there are no questions right now, so you can also, you can email me or anybody of us at any time, and we will provide you all the feedbacks. You will also get extra, as mentioned, you will also get all the information in the email sent after this presentation with the video recording of this session. So we will have plenty of time and possibilities to exchange all the technical and other information. Okay, if there are no questions, then I would like to thank you all for attending today's. There is one. One question from Ivan Sabo. Is it possible to design high voltage power lines? Well, basically, Electra was not designed for it. There are especially the poles needs to meet some other conditions, etc. And as you can see here, we are just modeling basically a low voltage power line systems and all the telecommunication systems. So we are more focusing on the general distribution in, let's say, in the city, in the suburbs, and not designing new high voltage power lines. Also, if you look at the market share, designing high voltage is pretty smaller than all the design that needs to be done in the local area, just connecting some new urban areas or some new industry areas, creating new telecommunication connections, etc. So we are now more focusing on that part. Okay, maybe any other question? Main competitors? Yeah, good question. So Autodesk has one software for it. It's called Utility Design. But compared to Electra, it offers only design in the layout, so you have no profile design. Let's say all the rest is similar. Another difference is basically maybe the price range. So that utility design is more expensive than Electra is. What the advantages of Electra is that, okay, it can be also quite cost effective because users can use it on BricsCAD, on plain AutoCAD, on maps, so they don't need Civil 3D for that. There is one competitor from Canada, it's called Powerlines. That one is focused on high voltage especially, but also for this part of where Electra is. What we have here are the tools for the underground design, which they don't have. So, there's always something that somebody has and the other doesn't have. Our focus should be, let's say, the cost of ownership and having all the possibility to do basically everything that a designer needs to do in designing of power lines or communication lines. Anything else? Is it already some company using Electra? Yes. In Slovenia there are electrical distribution companies, so there are 4 of them, and 2 of them are using Electra. And we have quite a number of users in the Balkan area. They were using the Electra 1.0 version, from years ago, and some of them are they upgrading to Electra 2015 version. But the Electra 1.0 had just the overhead power line design. What we are now focusing, or let's say what we are now trying to extend its functionality, is the mentioned underground possibilities for the design. So if you look around, plenty of companies are putting all the electricity in the city, in the suburbs, underground, and all the communication cables are going underground. So that part of the planning is very important. Electra also uses and enables the combination of those two. So one part of the power line can be underground design, and the next part of the power line can be underground. So there are those combinations. And especially if there are, let's say, users that already have some of our softwares, like, I don't know, Platea, Ferrovia, they can combine those tools to check, you know, all the crossings, etc. If they have a lot of work, well, there is Electra, so this electro distribution company, which I know most, and it covers 1/4 of Slovenia, and they have projects on daily basis. So we have been developing this new Electra in the last year, and we were giving them the, you know, the beta versions and whatever, and they were, I think they finished more than 10 projects. Okay, they were all small, but they had, like, you know, continuous projects to work on. So from our feedback, those distribution companies should be very interested in such softwares. Yeah, but you mentioned new designs. Basically, yes. If you look, there's every municipality is creating today, I don't know, a new area for development, for industry, or for housing, etc. So they just have to plan how to make, you know, how to connect all the electricity and the communications toward that area. So basically, wherever there is some land development, this kind of software is also used, because they just have to bring their, as there is a road that needs to be connected to that area, also the electricity and the communication cables needs to be designed there. Maybe the question would be whom to address. Well, what we saw from the feedback, especially if you look at in Slovenia, okay, there is the electrical distribution companies. That's the first one. The second one are the telecommunication companies. Okay, they are going over mobile now, but they have to connect all those mobile stations by ground as well. There are some cable operators, like for television cable operators, and there are design companies which do the design of power lines. So that's basically a field of, let's say, a group of 4 different kind of users that you can address, you know. Okay, anything else? If there's no question at this point, feel free to email me or anybody in the in CGS, and we will try to answer you as soon as possible. Thank you for attending today, and looking forward to, you know, to speak to you